This is the setup for cutting the 1mm pitch thread, and you'll see that the gears protrude at the back beyond the end of the spindle, which means moving the gear for the headstock further into the lathe and putting here a bush in to space off the 100 tooth wheel from the spindle. This is 100 teeth, 50 teeth and 30 teeth. 100 tooth, 50 tooth and 30 teeth wheels to give the ratio of a pitch of 1mm. And that's running with the back gear engaged, and this is my first attempt at cutting a thread, which is a very nice 1mm pitch thread. The way to cut these threads is to advance in to the work and then to cut no more than 0.1 of a division, 0.1 of a millimetre, which is one of those larger divisions there, into the work at a time, and about 4 or so, 5 moves inwards and the thread's completely cut. Although there's slop in the universal joints, it doesn't really matter. The threads formed are still accurate, because it pushes it up to the point where any slop there is taken out. There's a bit of slop in, a bit more slop in this end. But as I say, it doesn't seem to affect it too much. The thread produced is okay. So that's how I produced 1mm pitch, and I'll go now to put some different gear ratios in and cut something else. I set up the gear wheels now to cut 1.5mm thread pitch, and this is the arrangement of the gears, as you can see, much the same as the previous one, and this is ratios of 30 on the headstock, 30 as the first gear that it mates with, 52 and 70, so that's 52 and 70. And this is the thread that I've cut. I've managed to find a nut. I've only got one that fits M10. It's a nice sharp thread, and it fits that absolutely perfectly. I've just taken out the nylon, part of the nylon nuts. This is the only nut I've got, but it fits that fine. Perhaps worth just showing the tool that I'm using, which is a large size threading tool. These I've discovered are easily the best tools to use for threading, external threading that is, but the depth of the tool was a little bit too deep, so what I've done is I've machined 2mm off the underside of the tool, and that fits perfectly now. Although it's hard steel, it can be machined with a nice sharp fresh cutter with a little oil and running fairly slowly at about 1000 RPM. It's no good running it fast, you just mess the tool up. So I'm getting the hang of this now. That's 2 threads cut. I'll cut a few more just to be satisfied that I've got the ratios correct, This is the setup for 1.25mm thread, 30 on the spindle, mating with 55, that's a 52, and that's a 45, and that should give me 1.25mm cut, that thread, 1.25mm thread. And I now view this from above the lathe and you can see it cutting. Right, I'm ready now to cut the thread. I'll probably cut it, well, I will cut it short of this shoulder, and I have to be sure to be able to wind the slide out before it reaches the shoulder, otherwise it'll dig in. And the motor, you'll see, tends to coast on for a little while afterwards, but that doesn't seem to have been a problem so far, so I'll run it to about here, about 3/4 of the way down. I'll do the first pass just to check, to make sure that the thread's correct. Let's check that that's correct. Right, gauge. Yep, that looks like 1.25 to me. Hopefully that comes out on the video. So I'll just cut this now. You can see I'm cutting this Just a little bit more. Should be enough. That's an 8mm thread, 1.25, and that's a 1.2 an 8mm nut, which is fine on there. You can see that it's difficult to get an absolutely clean thread at the end, and the only solution to that is to use a crank handle to turn the lathe with. And I've made a crank handle to turn the lathe. So that's an option that enables you to wind up to the same point easily. But that is now a thread cut. So that's the third one I've cut, and that's perfectly okay. So the thread cutting attachment actually, surprisingly enough, works quite well. I've set this up now to take a cut of 0.25mm, and this is mild steel, so I'll fire this off and see how we go, and then I'll take a deeper cut next. Now I've got a cut of 0.5mm. And now a cut of 0.6mm. I spent a little bit more time on the top slide and the fit between this block and the V-ways down here. This is quite a complicated piece to get to fit properly. The underside of this block here sits on top of this piece, which is that piece there, and it also sits on the outside flange, and it sits on the dovetail underneath and on the dovetail on this side, and that is quite tricky to get to all fit together, and I discovered that if you just ease this a touch on this surface, it then brings this more into play. So that's one thing I've done. And the other thing I've done is that the dovetail on the inside of the block here was slightly bowed like that, so it was causing this to twist slightly and not give a nice smooth finish when I was machining. So I've re-scraped in the inside part of the V-way, and that's pretty good now. I can now show you that, and this is having taken two very light cuts just to show how it is. Quite quite a nice finish from that now. And this is only a very cheap indexable tip. So that I'm really quite pleased with. The net effect of that now is as good as one would expect any lathe of this sort of size, like a Myford, to work, and is actually slightly better than I thought I'd get out of it. So it's certainly quite a usable lathe for the average person. I've got the gears all working. I can cut a good selection of gears, and I was going to fit an electronic lead screw, but I'm sort of doubting whether I need to now, as everything seems to work reasonably well now as it is. I'll think about that later. I'll get it to work, and then I'll come back to this afterwards. I spent a bit of time scraping in the attachment where the top slide fits to the cross slide, the circular part. That's now in a plane that's the same as the top of this bar, and I can show you that now. This is running the full length of the top slide. That's within 0.01 of a millimetre over the length of this, so I'll now be in a position where I could machine something over a 10-11 inch length and then move it further up and machine a further section of the same piece and get the two to run together seamlessly. So I'm quite pleased with that. That accuracy is now the same on top, and I just need to make sure I've got the dial gauge working the same on the sideways movement. And I think, given I've adjusted this, I think it probably is about right now. I'll check though. I've now set up on the horizontal side so that it run along the test bar, so I can see how accurately I can manage to get it set up. I'll run this out to the end of the test bar. It's quite difficult actually to get this set up. Quite difficult to get this set up so that the top slide is adjusted so it's exactly parallel. But if it is exactly parallel, it's really not bad. It's quite close to being within a 0.01 of a millimetre. So I think I'm happy enough with that. That should certainly be fit to use as it is.